Started. Um, Question that your author comes up with here at the very beginning of chapter 12 is hunger, eating, and health. So why do many people eat too much? And we'll really end the chapter with talking about some of the disorders in overeating or undereating as well towards the end of the chapter. But let's go ahead and get started. I do want to let you know that this is one of those chapters. Remember, week 10, you have chapters 12 and 13 that you're responsible for. So you will definitely want to review the PowerPoint slides for chapter 12 and 13 before you start reading the book, is what I would do. Because there are large sections of the book that are not going to be covered. I took the most important material, in my opinion, out of both of these chapters. And I know that you have a midterm this week, and so it took all of that into consideration, but specifically because we have two chapters to cover, 12 and 13, that they will be condensed quite a bit. Okay? All right. So control of eating. Is there a set point for the body's energy reserves that determines when we eat? That's a good question, and that's something that we're going to be looking at as we go through the lecture today. A lot of people, they believe that it's just a physiological process. Hunger pains, maybe feeling a little lightheaded or something like that. Okay, I need to get something to eat. But we know it's not that simple because we snack on stuff all day long. We obviously eat stuff that tastes really good to us, and we overeat food that is also really good to us. And sometimes we eat just because it's the time of day that we're accustomed to eating, correct? So those we'll get to in a little while. But the prevalence of eating disorders suggests that this may not be the case because over half of the adult population in the U.S. meets the criteria of obesity. The average American consumes 3,800 calories per day, and that's about twice the average. And 3% of U.S. adolescents suffer from anorexia or bulimia, which is the other side of the coin, right? Where these are the people that are extremely thin, emaciated, and yet they still see themselves as being overweight. Okay, so the purpose of eating is to provide the body with molecular building blocks and energy. Digestion is the breaking down of food and absorbing its constituents. But the first thing here is that the purpose of eating is to keep us alive. So if you think about it, when food wasn't as plentiful, when food wasn't just in your icebox, your freezer, your refrigerator wasn't just sitting in a basket on your table all the time, you had to hunt and gather for the food, and so it wasn't always just readily available. And so in that case, it was really survival, right? You need that food to survive. Okay, not important that you know all of all the terminology and everything step by step, or I'm not going to ask you what's the fifth step in the digestion process or anything. Just kind of gives you some framework for where we're going. Okay. So now talking a little bit more about that same pictorial representation of the gastrointestinal tract, energy is delivered to the body as lipids, amino acids, and glucose. Energy is stored in the body as fats, glycogen, and proteins. And fats are most efficient for energy storage. It says 1 gram of fat stores twice as much energy as 1 gram of glycogen. Fat does not attract and hold as much water as glycogen either, and so it provides for a denser energy storage. Okay, now there are 3 phases of energy metabolism. Page 289 in your book talks about this. You have the cephalic phase, which is the preparation for eating. You have the absorptive phase, which is when the energy is absorbed. And then you have the fasting phase, which is withdrawing energy from the reserves. Okay, and then the fasting phase ends with the next cephalic phase. Okay, when you're preparing for the food once again. Um, what I did was I just skipped over some of the information there, and I like the figure that they provide you, figure 12.3, because it puts it all together anyways for us. Okay, so let's say that there's the cephalic phase. This is the preparatory phase, which is initiated by the sight, smell, or expectation of food. So now what we're going to do is we're going into more detail about what are the brain areas that are responsible for the sight, smell, and expectation of food, and that kind of thing. But for right now, we're just talking about, here's the preparatory phase. Insulin levels are high, so they're getting ready to be injected into the bloodstream. And then the utilization of blood glucose as a source of energy, conversion of excess glucose to glycogen and fat, conversion of amino acids into proteins, and then storage of glycogen in the liver and muscle, fat in adipose tissue, and protein in muscle. Okay, so that's at least going on in the cephalic phase. But those things are also happening in the absorptive phase, where nutrients from the meal itself is meeting the body's immediate energy requirements, with the excess being stored. Here you have the glucogen levels low, and we already went over what it promotes. What it inhibits here is the conversion of glycogen, fat, and protein into directly utilizable fuels, utilizable fuels, glucose, free fatty acids, and ketones. Okay? And then at the bottom you have the fasting phase, so energy being withdrawn from stores to meet the body's immediate needs. For most of us, this fasting phase is going to be, probably 4 or 5 hours long, 6 hours long, okay? Because we eat pretty much on a routine basis. Very few of us are going 24 hours or 48 hours without any food. But let's say that you did go 12 or 24 hours. You would definitely go into a fasting phase where energy would be withdrawn from stores in the body's immediate needs, right? Glucagon levels are high, insulin levels are low. There's the conversion of fats to free fatty acids so that they can be used. There's the conversion of glycogen to glucose, and free fatty acids to ketones, and protein to glucose. So it's the opposite reaction, right? The opposite process going on here. Inhibits the utilization of glucose by the body, but not by the brain. Conversion of glucose to glycogen and fat and amino acids, protein, and storage of fat in adipose tissue. Okay, so you can see that really the cephalic phase, absorptive phase, is kind of the opposite of the fasting phase. It only makes sense that in the absorptive phase, we're storing glycogen into fat, adipose tissue, protein into muscle, and then in the fasting phase, we're taking that protein out of muscle, right, and putting it back into proteins and so forth. Okay, so theories of hunger and eating. I chose 2 of these: set points and positive incentives. There are some others, and we're not going to be talking about those this time, but let's talk about set point. Okay, hunger is a response to an energy need. So we eat to maintain an energy set point. So think about that. If the only reason why we eat is to maintain an energy set point, what do you think about that theory? Okay, I'll let you think about that a little bit. The typical assumption is that eating works like a thermostat, a negative feedback system. It turns on when energy is needed and off when the set point is reached. Well, you can probably think to yourself already, it's too simple, huh? Too simplistic. There has to be more to it. We don't just eat when we're hungry, and we don't quit eating when we're full. Okay, so it's not quite like a thermostat. But let's say if the set point was true, this is what you'd be looking at, right? After 3-4 hours, then you eat, then the energy reserves would raise back up, energy reserves would go down, 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 then you'd eat again, and etc. You'd have that cyclic process. Okay, what about this? If we eat to maintain an energy level, what is monitored? Is it glucostatic, which means that glucose levels determine when we eat, or would it be lipostatic? Fat stores determine how much we eat over a long term. Okay. So if it is this set point, this homeostasis that we have to stay at, is it triggered by glucose or is it triggered by fats? Okay. These theories are contrary to evolutionary pressures that favored energy storage for survival. You have to remember that you look at a lot of the animal species and look at other carnivores like humans, and you're going to see, let's say, a large cat. Okay, a large cat, they don't eat every day. Okay? They might eat once or twice a week or once every 2 weeks, right? But then when they do eat, they eat a lot. Okay, so this is kind of going against that. If they were, I'm sure they were hungry 2 or 3 days after the last time they ate, but they might not get another meal for 7, 8, 10 days. When they get that meal, they don't stop eating when they just feel full. So there must be some other components to this picture. Reductions in blood glucose or body fat do not reliably induce eating, and these theories do not account for the influence of external factors on eating and hunger. Like I mentioned to you before, we eat stuff that tastes really, really good, and we eat too much of it, or we just eat because it's time to eat. What about the positive incentive perspective? So we are drawn to eat by the anticipated pleasure of eating. We have evolved to crave food. There's multiple factors that interact to determine the positive incentive value of eating, and this accounts for the impact of external factors on eating behavior. And this theory is much more accepted today, and I think you can think why. Okay, physiological research on hunger and satiety. The role of blood glucose, the myth of the hypothalamic centers, role of the GI tract, hunger and satiety, peptides, and then serotonin. We're going to hit each one of these separately. So blood glucose drops prior to a meal as preparation to eat. Blood glucose must decrease by 50% to trigger feeding. Pre-meal glucose infusions often do not suppress eating, and reduced blood glucose may contribute to hunger, but changes in blood glucose do not prevent hunger or satiety. Okay. Experiments suggested 2 hypothalamic centers. You have the ventromedial and then you have the lateral. Okay, so ventromedial hypothalamus and then the lateral hypothalamus. The first one, ventromedial, again a satiety center, and then lateral you have the hunger center. But lesions of the ventromedial hypothalamus produce hyperphagia, so this would be a condition in which the animal, in this case, and primarily rat subjects, they just continue to eat and eat and eat. Okay, lesions of the lateral hypothalamus produce aphasia, which is the cessation or the stopping of eating, and edipsia, which is also that's the stopping of even drinking. Okay, so they just remember all of this hypothalamus, even all the way back to chapter 3. We talked about hypothalamus, we talked about drives, the drive for hunger, the drive for thirst. So that's what we're hitting right here. Okay, ventromedial seems to be associated with that overeating or hyperphagia, and then the lateral is aphasia and edipsia, which means that they just stop from eating or drinking. Okay, here's a diagram that's showing you ventromedial hypothalamus at the very bottom there, and then you have the lateral hypothalamus. Okay, the lateral being in yellow, the ventromedial being in green, so it gives you an idea of where we're looking at. Okay, now the ventromedial hypothalamus likely is not a satiety center. Again, it was a theory because VMH lesion rats maintain a new higher weight, and VMH lesions may non-specifically destroy other brain regions. We alluded to this in, I don't know if it was last week or the week before, where it may have been, yeah, I think it was chapter 11, where damage, it may not be so much the damage in this one area, but it's the depletion of neurotransmitters in this area that cause widespread abnormalities or widespread damage to other parts in the brain. Okay. And then the lateral hypothalamus, the LH, likely is not a feeding center either. LH lesioned rats will recover if kept alive by tube feeding, and LH lesions may produce sensory and motor disturbances that affect food seeking. Okay? So the most supported role of the hypothalamus is the regulation of energy metabolism. Okay, so that is the hypothalamic theory. And then we talk about the gastrointestinal tract. Studies suggest that stomach contractions led to hunger. Okay? However, hunger is still experienced by those with no stomach. So individuals that have an existing GI tract, but they don't have a stomach, and they still feel hunger. So remember how I mentioned to you just a little while ago that these hunger pangs, some people believe, well, it's a hunger pang, and so I'm hungry, and that must be a cue that I need to eat food at that time. Okay, and I'm not saying that it isn't, but it's just not maybe the entire picture. The hunger pang might be one component that's in this whole picture of insulin levels, glucose levels, the hypothalamus, sending out its signals. It's just much more complex than any one of these by themselves, any one of these theories by themselves. Okay, there's also peptides, cholecystokinin, and others, and they can decrease the meal size. They must first establish that that a peptide does not merely create illness, because CCK causes nausea at high doses, but low doses, it just suppresses the food intake. Okay, and then the last one on our list here was serotonin agonists consistently reduce rats' food intake. So even intake of palatable food is affected, reduces the amount eaten per meal, and preferences shift away from fatty foods. And similar effects are actually seen in humans. So when we're looking at those SSRIs, those serotonin selective reuptake inhibitors, some of these are being prescribed for for depression. They're antidepressants. They're serotonin selective antidepressants, and they're also helping with some of the eating disorders for this reason. Okay, they reduce the amount eaten per meal, shift away from fatty foods. So those are all very good signals, and you can see that somebody who's clinically depressed, they might eat. Okay, for their psychological reasons, they're eating because maybe that food is the only thing that it is providing any kind of positive environment or positive feelings for them, right? But then also clinical depression goes hand in hand with very low serotonin levels. So this makes sense. Okay, human obesity. Why is there an epidemic of obesity today? Evolution favored preferring high-calorie food, eating it to capacity, storing fat, and using energy efficiently. And for a lot of us, we've forgotten some of those. So what we do is we prefer high-calorie food. That is not unlike what we used to do. They eat to capacity. We don't eat to capacity. And in some cases, like I was telling you with the animal products, they don't either. They store the fat. But the big one here is that using energy efficiently. Okay, without exercise, without movement, it's throwing everything out of balance. So you would have to eat far less than what we're currently eating because we are just not active. And you can imagine that, again, when we had to hunt and gather for our food, the amount of energy, the amount of exercise that was exerted was phenomenal compared to now. So you took down an animal and you could eat your fill of that animal and you'd have no ill effects whatsoever because you were probably going to go the next 2 or 3 days without much to eat and do a lot of exercise. Okay, so instead of, like that other slide was telling us, 3,800 calories per day, we're looking at maybe 4,000 or 5,000 calories in one day, and then very little caloric intake for 4 or 5 days remaining after that. So it would definitely average out to be far less than what we're consuming now. And this kind of goes hand in hand with that. So why do some people become obese? Energy input differences, so craving for high-calorie foods, cultural norms, a large cephalic phase response to sight and smell, also lack of exercise at the bottom, lack of diet, and then genetics interact with both the energy input and output. So treatment of obesity, we saw how serotonin affects it, so that makes sense that serotonin appears to increase short-term satiety signals associated with the consumption of a meal. So it decreases the urge to eat, consumption of fat, intensity of hunger, size of meals, number of snacks, and early serotonin agonists produced. Oh, sorry, didn't want to go on to that last bullet there quite yet. So you think about these. And you're looking at them, well, it's perfect, serotonergic agonists. These are exactly what we should be providing people. But if you look at the very bottom bullet there, early serotonin agonists produce heart disease in some patients. And if you were familiar with the whole fen-phen, they call it fen-phen, fenfluramine, and phentermine. They used to hand this out even in medical clinics and so on for people, and they said, well, it's going to help with your depression and helps with weight loss and everything else. But they were quite harsh stimulants, and it did have an effect on their heart, and now they don't run those fen-phen clinics or anything like that as of today. Also, there's gastric surgery, gastric bypass, and the adjustable gastric band create a smaller stomach. Treatments are for extreme obesity. These treatments are effective in some patients. But again, you think about it, okay, remember, even if the stomach was removed, the person would still feel hunger. So they feel hunger, they can only eat a little bit, but there's so much of it is a psychological component, and you have to look at the person, the whole picture. You have to look at the family environment, to really help these people. It's not going to be as simple as just gastric bypass surgery. And then we have anorexia and bulimia. Anorexia is the voluntary self-starvation. It's fatal in 10% of patients. Bulimia coincides with binging and purging. And the two illnesses have similar symptoms and can be difficult to distinguish, like distorted body image. Most often affects educated, affluent young females, and associated with obsessive compulsive disorder and depression. So these people, they are depressed, and they feel the urge to possibly binge or purge in the case of bulimia, or they just don't eat in the case of anorexia because they feel as though they are always overweight. Okay. Hypothesis here is that a person out of homeostatic balance might find a full meal to be aversive in the case of anorexia. So eating a meal would then lead to the development of food aversions. Feeding meals to famine victims sometimes leads to anorexia. And the implication is that anorexics should eat small amounts of food throughout the day as part of their therapy. Okay, and that will do it for our chapter 12. As I mentioned to you, there were several things that we left out there, but I want to end with the e-lecture topic item here, and this is going to be number 1. So you'll have e-lecture topic item number 1 in chapter 12, and the e-lecture topic item number 2 in chapter 13. So this one's worth 10 points. It says set point theory suggests that attempts at permanent weight loss are a waste of time. On the basis of what we have learned in this chapter, design an effective and permanent weight loss program. Okay, so it's pretty subjective there, but provide me a detailed response. Remember, it is worth 10 points. Okay, and that's it for chapter 12.